Hi, this is Dr. Subhatra. In today's class, I am going to discuss about the mineral admixtures. The mineral admixtures are fly ash, silica fume, ground granulated blast furnace slag, metakaolin. In this class, I am going to discuss in detail about the fly ash. So fly ash is a byproduct obtained during the combustion of coal in the thermal power plant. Nearly 73% of India's electricity generation is by means of coal burning. Therefore, 120 million tons of coal ash is produced annually. About 10% of the fly ash is only utilized by the industries, and the remaining 90% is dumped into the landfill. The utilization of fly ash is the matter of primary concern, and the disposal is a major problem in fly ash. The quantity, the quality and the composition of fly ash depends upon the type of coal which is being burnt. So this is given in the ranking order. So the top ranking is the lignite. The coal used is a brown coal. The fly ash produced from this lignite will be of a good quality. And the fly ash produced from the anthracite, that is a hard coal, high temperature needed to burn it, will get the fly ash of low quality. So the ranking is given as such: lignite, sub-bituminous coal, bituminous coal, semi-bituminous coal, and then comes the anthracite. So low rank coals contains more impurities. So this anthracite, around 90 to 95%, which is a hard coal, has much more impurities in the fly ash what it is producing. So fly ash is not very common because of the following reasons. Okay, because of the poor marketing, because of the storage problem, the conservation attitude, it contains many toxic chemicals. Moreover, we are calling it as a waste instead of calling it as a pozzolanic material. Now many researches are going on, and now we are taking this fly ash as a pozzolanic material. During combustion of coal, 75 to 80% of the ash flies out. That's why we are naming it as a fly ash, since it is capable of flying. And the remaining ash which is collected at the bottom is called as a bottom ash. The collection of fly ash is done by means of two types of precipitators. It is a baghouse precipitator and electrostatic precipitator. This baghouse precipitator is more efficient. It removes the very fine particles. This is the picture of the electrostatic precipitators. Here the dust laden gas is allowed to pass between the plates. When it is moving around, all the dust particles are collected. All the dust particles are collected at the bottom by means of a hopper. This collected dust is the fly ash, and here the clean air is coming out. Okay, these plates are the grounded collection electrode plates with the high voltage supply. This is the working principle of an electrostatic precipitator. This, the ash which is flying in the air, is just separated at the bottom of the hopper by means of a high voltage supply. So where this fly ash is used? It is used as a mineral admixture. It is used as a synthetic aggregate. The resultant aggregate can be used for a lightweight concrete also. Aggregate can also be synthesized by agglomeration process, and it can be used for cold bonding. There are two types, type C and type F. Type C as a high calcium fly ash. It possesses both cementitious property and pozzolanic property. Only 10 to 15% of the material has a particle size greater than 45 micron meter. The average size of the particle is less than 20 micron meter. But in type F, this is called as a low calcium fly ash, just a reverse of type C, and is normally it is pozzolanic material. 15 to 20% of the materials is larger than 45 micron. Here it is lesser in size. Here it is larger in size. The particles are solid spheres with a smooth texture, and the average particle size is around 20 micrometer. What are the effects of this fly ash on fresh concrete property? It increases the setting time, it increases the workability and the flow of concrete, it reduces the segregation and bleeding. As the paste volume increases, it can be used as a replacement material for cement also. What are the effects of fly ash on hardened concrete? The strength gain of the fly ash is lower than the normal concrete. Ultimate strengths are usually improved when fly ash is used. Creep and shrinkage are typically higher than the normal concrete. Okay, then the pozzolanic activity is proportional to the amount of particle under 10 micron meter in diameter. So these are the effects of hardened concrete properties. More air entraining admixture is needed. The results on the effect of fly ash on sulfate resisting are inconclusive. Expansion occurs. Our expansion due to alkali aggregate reactions are reduced because of this fly ash. This is the effect of fly ash on the hardened concrete properties. What is the use of fly ash in specialized applications? We can use it in the high strength concrete. In roller compacted concrete, you can use it. As a synthetic aggregate, we can use that. In controlled low strength materials, we can use it as a flowable mortar for that too, particularly for the backfill. So these are the applications or the effect of fly ash on fresh concrete properties, hardened concrete properties, its uses and applications, what are the types of fly ash, and why it is named so, how to collect that ash, all the parameters or all the areas we have covered in this class. Thank you.